By the way, we completely skipped over Sonnet 3.7.
Oh God, yeah.
It's
Big release.
so amazing.
Yeah. Pray tell.
So Sonnet 3.7 has topped all the benchmarks.
Okay.
Especially the thinking model. So it's still called 3.7, but it's called 3.7 thinking because
It's just a reasoning model.
was,
Trademarked or something. Yep.
I
Contaminated.
wonder if they actually had reasoning internally. They also have this thing called the Claude command line tool or Claude code. And you basically run Claude in your command line and it does whatever you want it to do.
Okay.
It reads files.
Oh, it's computer use, but purely via the CLI.
Yeah, it's kind of like a developer. It's like a developer in your terminal.
Okay.
It reads files. One thing I noticed when I was using it is I would be like, do this weird thing, and they would go, okay, and then it would start grepping the code base and just looking for files to read. So it's a really, really sophisticated model, and people are spending a lot of money on it. Like, I mean, I'm spending like $5 every time I use it, just because.
Whoa.
Yeah, it's very expensive.
3.7 thinking
right?
specifically.
Yeah. So a note on 3.7, as far as I know, it is the exact same pricing as 3.5.
Okay.
But people are with thinking generally
You end up
has more
consuming an
output
enormous
tokens.
number of tokens.
That's
Okay,
right.
Yep.
And also with Claude Code, you just kind of build up your context as you work with it.
Yeah.
And it doesn't clean the context unless you ask it to with a compact
Yeah,
command.
okay.
So you kind of get this big context after a while.
Do you remember the ratio of like input to output token cost or anything like that?
I don't know the ratio, but let's see.
So as far as I understand, it's commonly something on the order of about 4-1. And so, input tokens are cheaper, but not cheap per se.
Okay, so here's what we've got: $3 per million tokens for
input
Claude
tokens.
input.
Okay, yeah.
So this is the same as 3.5. I think.
And it's 15 for the output, so it's a 5-1 ratio. Okay.
Oh, that's what you meant. Yeah,
Yeah.
5-1 ratio. Yeah, I never think about that. Do you think in those terms? I guess it does make sense because for thinking. But basically, what thinking is doing is outputting a bunch of tokens for the LLM thing.
Yeah, it's inference time compute.
Yeah,
it's all inference compute is the expensive bit, and you're cycling on an output token that it rereads as more input.
Right.
So yeah, interesting. Okay, that's pretty sick though. I mean, if it's the best model out there and the reasoning models are good, you ask them to do something. I love the fact that it has the lower than greater than think at the start. And it's like, okay, I need to think about this for a minute. It's like, you consciously decided to do that. When I say consciously, people are going to have a problem with that term. But,
Right. Let's see where it is on the benchmarks too. I haven't checked this in a little bit. See if we've got it on the ADER. I love this polyglot leaderboard. Yeah, it's topping it out. Yeah, I actually hadn't read this yet. So 65% on the polyglot leaderboard, beating DeepSeek R1 plus 3.5 and beating O1 High. So
O1 High.
Yeah, O1 High. Yeah.
Ooh, OpenAI.
So,
oh no. Really neck and neck there, isn't it?
Yeah, I actually switched some stuff to. So I wanted to build. We were talking about AI generated circuits. So I've been building a chatbot for TS Circuit.
Okay.
Hopefully help people learn, also help generate circuits.
Yep.
And I used this template from Vercel, and they're super dependent on function calling. Pro tip to AI developers: do not rely on function calling. Function calling is when you tell your AI, hey, these are things you can do.
I see.
And then it'll call those functions.
Yep.
So because of Vercel, I ported everything to OpenAI. And then this happened. And this is, of course, way better at everything. So now I got to figure out what to do. But for people building chatbots, Vercel's chatbot template is a pretty fucking good looking chatbot.
Okay. Yep. Nice.
It's great for demos.
great for demos. That's good to know. Simple hacks. So this ADA, how frequently do the positions on the top 3 slots in this ADA performance list, or what's this called?
The polyglot leaderboard for ADA.
Polyglot leaderboard.
Yeah.
Okay. So how frequently does the top position on that change?
I would say the top position changes every 2 months, if I had to guess.
Oh, 2 months.
Yeah,
okay. So
every
it's
3 months.
It's frequent. You got to keep up with it, but it's not like weekly. So it's still big news when it happens.
Absolutely. And I think, I don't want to be wrong about this, it might be a released one, so maybe people are cheating it, but I've never felt like it was wrong. I've never used it and gone, okay, I don't think this is right. DeepSeek was so good. So when DeepSeek kind of got to the top, I was like, yeah, that makes sense.
Yep. Yeah, that's incredible. Wow.
Yeah.
And so what do you bother to switch thinking on for?
Yeah, it's a good question. I think when yeah, you kind of get a feel for like a hard problem, like you don't know how to explain it. One thing that's really nice about thinking is you don't have to explain your prompt as much. You don't have to add as many details. So if I ask what is TS circuit to just Claude, it assumes that it's something with time series and circuit because of the TS.
Yeah.
But with the thinking model, it will kind of think about it and be like, oh, it's probably TypeScript and not time series.
Okay.
So.
And so that's interesting. When you talked about the function calls as well, are any of these thinking models able to execute? No.
Thinking models are just so bad at any kind of like structured approach, which is why I think Vercel isn't using them. Function calls are going to be for enterprises, for people building like real world applications. You do want to be hyper predictable. You don't want to take the risk on the thinking models. And I'm assuming that they just need to tune the thinking models to be able to do function calls, and eventually it will get there. But if
the thinking models were able to do function calls, you kind of need to be able to it needs to be able to think, go, I actually don't know what I'm talking about, or I don't have enough context, and decide to call some function, to do some research.
Do you know how they teach LLMs to not know things?
Yeah, I have no idea.
It's a really crazy technique. Andre Karpathy talks about it in his most recent video. He does this long tutorial on LLMs.
Oh, cool.
And basically, you have to figure out what's knowledge the LLM does have, and you construct questions that kind of tell you what it knows and what it doesn't know. And then in the reinforcement learning phase, you ask those questions and you penalize it for guessing. So what we've learned recently about LLMs, and Andre talks about this a lot, is that reinforcement learning is basically the phase of training an LLM where it starts to exceed the data you gave it. It starts to have, what do they call it? Emergent properties.
I see.
Yeah. So that's like a really exciting thing.
Yeah, it's like a 2-year-old, and it's
basically.
Yep. Okay.
I think that'll be exciting for autorouters too. Once you have kind of this compressed data set and you start to tease it with reinforcement learning. I think reinforcement learning causes it to like basically remap itself internally and kind of like realize what's important and stuff like that.
Yeah, interesting.
Yeah, it's very exciting.
Become very biased about which paths are worth following and which...
Exactly.
Yeah, interesting.
Yeah, start to get opinionated and less of a compression and more of like a tool.
yeah, interesting. They're still rocketing along at an insane pace.
Yeah, it's crazy.
I think we're going to be writing a Moore's Law like AI scenario for the next while at least.
Yeah. The next big release that we know about is probably O3.
Okay, yep.
Yeah, OpenAI has been teasing it with the highest benchmarks, but
well, they're going to have to do something good because they've been overtaken a few times now.
I do feel like they really want to get a substantial lead because they know that people can build on top of whatever they do.
Yep.
And they wait out for that substantial lead.
Yep.
And then they basically somebody forces their hand and then it's not exceeding that much. Like O3 Mini for me was a little bit of a letdown because it was kind of worse than DeepSeek in my opinion.
Yep.
And kind of worse than Sonnet.
Yeah, interesting.
In a lot of ways. So.
Yeah. And Anthropic's an interesting one because they're much less known. They didn't make the splash of DeepSeek, for example. It just came onto the scene and became, it's like news title, headline name everywhere. And OpenAI is, you think of as the leader.
Yeah.
Google kind of feels irrelevant, even though they're kind of the biggest in many ways. Like every time you search
they're
on
kind of
Google,
hard to use. I don't know. Like, I don't want to use the Google console thing.
But when it comes up at the top of Google, it does a good job. And their models, according to all the benchmarks, are fantastic and all that type of stuff. So they do well. Anthropic, I guess, is just a particularly, almost seems like a niche within our scene.
Yeah, absolutely.
Software engineers love it. And it's kind of something not a lot of people haven't even heard of.
Yeah, I think OpenAI might be spread a little bit thin in some sense. Like they seem to work for a lot of industries. And I think if you're selling into enterprises, you probably don't need like a strictly coding model.
Yep.
But I think Anthropic, how they tune their data is just really, really good. Like it always blows my mind when Anthropic is executing how it's like always going to execute. Like it's always going to work.
Yep.
So they really know how to tune the model to only know how to output code that'll work. And I think they're actually fixating more on the developer use case.
Yeah.
And that's why they're winning at it. OpenAI just with their strained focus can't do it. They'll probably make more money by being more general.
Yeah.
But
it's a long-term question though, because you're talking about software engineers who are commonly willing to pay the now, whatever $200 thresholds just to see what OpenAI has to offer.
True.
And so if Anthropic were to release something truly groundbreaking, and you'd have people paying $200 a month for it, which
Absolutely.
I hope they wouldn't be losing money on, but they could be depending on what the inference costs were.
I probably spend over $200. How much do you spend? What's your like cost per day? I probably spend like $500 a month on Anthropic right now, just usage. Yeah,
that's
I
crazy.
told you each time I use the terminal now.
Yeah.
I'm like paying $5.
No. I'm not actually. Most of my Anthropic usage is now via Cursor. So
Okay.
I give them not a huge budget. I think it's $30 a month or something.
Oh, okay.
So, I pay for Claude. I pay for OpenAI, ChatGPT plus services and API subscription. And I pay for Cursor, which sort of sum up to somewhere of $60, $80, whatever that comes to.
Yep.
Plus another $20 a month. So call it 100.
Yeah.
And that's my personal AI use plus some agents and bits and pieces going on in the company in the background.
The reason I'm spending too much probably is I also give, if you're a contributor to TS Circuit, a lot of times I'll give you an API key or something because I want you to contribute better.
Yes. Yeah. We do the same. We buy a subscription for some key contributors, but I'm not putting that under my my personal title. The company spends a lot more on AI. But
Absolutely.
I can't consume that many tokens myself.
Yeah.
Not that usefully. The benefit tapers off pretty quickly.
Yeah. It really does feel like with contributors, you can take anybody, any random person who's just motivated enough.
Yep.
And if you give them AI, they'll really be able to figure out basically every issue. Like a lot of times when a contributor who's very junior comes in, I'll just be like, what AI are you using? And then I will show them how to use the AI rather than answer their question because you have everything you need now if you do want to get into contributing to open source and stuff like that. Everything's out there.
Oh, it makes it so straightforward. There's one library or one module, I'm trying to remember which. Anyway, it's for PathSpec. It's for basically parsing gitignore like files and then traversing the tree of all those files to work out which ones are ignored and which ones are matched. And trivial, like relatively minor library. And I was like, man, the way it's iterating through this tree is really inefficient, and it actually ends up taking a second or two at the startup of actually some test suite software.
Yeah.
And I'm like, well, a second or two is not the end of the world, but it's kind of annoying considering it's an interactive command.
Every second matters on your test suite.
Every second matters on your test suite. Every second matters a heck of a lot more when you're running it like the command yourself. And that's in CI it's one thing, but if you're running it yourself, God, is it annoying that the spool time's that long?
Yeah.
And so, so what it's doing currently is iterating the whole tree for all the files and then filtering those for matches. Whereas with a git ignore, if you've ignored a whole directory or .git itself, you could not bother to iterate over 10,000 files.
Right.
Which is going to actually save a material amount of time.
Oh, absolutely.
If you can change where you do the filtering.
Yeah.
If you do it as you recurse through that directory structure. And I thought, is this actually something I should do? I'll just write a function. It's like, wait a second, making this contribution back is like kind of trivial.
Yeah.
A little bit of a help from AI, particularly, oh my God, to write the test to make sure it's all working properly. And hey presto, I can do something that benefits myself, the community, and get it back out into the world.
Absolutely.
It's a good way to be.
Yeah, absolutely.
So I've teased for a little while, to you in person about my experience at Lilium, but while the company was still functioning, there's all sorts of bits and pieces that you wonder which details you can mention. And now that, very unfortunately, I should be clear, they've just gone through their second round of insolvency. And it's the second in the last 6 months. It seems like, unfortunately, this time they're dead because the investors that were supposed to come through at Christmas kind of just never really sent the money. Hey presto, what can you do?
So they declared bankruptcy. Some investors said, we're going to save you, but then they didn't save them.
Hollow promises. Yeah.
I see.
And so the companies sort of limped along with, sort of ghost team and employees sort of, oh, cool, no worries, it's coming back. And it's just sort of not.
So what is Lilium, first of all?
Of course.
Very, very interesting company.
Yeah, super. Very similar to Joby or Archer, they're an electric vertical landing and takeoff, or vertical takeoff and landing, VTOL, aircraft company. So they make what kind of looks like a plane, but it can take off and land vertically like a helicopter. And they're typically all electric as well. And there's sort of new generation of passenger eVTOL aircraft. And it's based in, or was based in, just outside Munich in Germany. And,
So a German company.
German company, sort of. They had American stock, German company, registered in the Netherlands. Very classic kind of big corporate
They
structure.
went through the SPAC I saw. I know very little about Lilium, but I did see that they went through the SPAC when SPACs were hot.
They went, SPACs are so hot right now. Yeah.
We should explain SPACs too. So a SPAC is, actually, what does it stand for? I don't know.
A SPAC is basically a backwards way to get onto the stock market. And what you do there is you start an entity that meets all the auditing requirements, which is quite hard to do in order to get onto the stock market.
So the company that started is the Special Purpose Acquisition Company. That's the SPAC. Okay.
Yes, exactly. And the point of this SPAC entity is they say, we think eVTOLs are going to be big, invest in us, and we'll pull up all the cash from purchasing stocks in the company, and we'll reinvest that at some point, basically wholly purchasing some other company, in this case Lilium. And then the SPAC is just a shell. It's a super thin wrapper to do nothing other than
It's like a guy.
Yeah, exactly. It's doing nothing other than meeting all the quite hard auditing requirements to get onto the stock market. But then when you make a large purchase like that, you're doing what you told the investors you're going to do. It's it's only minorly questionable.
This
but
is
it's
kind of
much
like
easier.
why Elon wanted to take Tesla private. Is he hated these requirements or something like that,
they're
right?
super annoying.
So he was like, "Oh, I'll take it private so I don't have to deal with this." So a SPAC is going to handle a lot of that for you.
A SPAC handles, in order to get it onto the stock market in the first place, it handles that all for you. So they did that years ago, after my time there, but probably 2.5, 3 years ago at this point. And that means that anyone could have traded their stocks, which is, it's kind of fun. We weren't able to sell them as employees immediately after it went on the market because they didn't want to cause a flood of ex-employees or employees just selling off their stock,
Right.
And unfortunately never really tipped out anywhere near what it immediately went to ever again.
Oh, interesting.
In terms of the value. But really interesting company, and I should say incredible group of people. It really attracted some awesome talent, and a lot of fun. Also a few interesting stories out of the place, because you can imagine it's a German company. It's in aerospace, and so highly regulated. Germans, they love the rules. Oh, so many rules. And they love processes and that type of thing, as does aerospace. And yet simultaneously, they're a startup that has a prototype that is, for the sake of the engineers, is overweight and at some point literally won't take off because you need to shed kilograms.
They had a working prototype of this plane, right? It could seat 6 people or something, and it could take off and all that, right?
Yeah, the 6-person prototype was a little bit after my time, so I don't really know anything to speak about that. But the Phoenix prototype, which is a unmanned, basically a big RC plane that had no seats at all. The whole cabin was full of batteries by the end of it.
Oh, interesting.
But it was practically designed to carry 2 people, and you can imagine they just sort of ripped out the seats and filled the thing with instrumentation and batteries instead. But you can imagine it's a big carbon fiber jet. It looks just like it's a canard-based plane, so it's got short wings on the front instead of a tail, and then long wings in the back, and all of its flaps are covered in its propulsion system. So it's got 36, I believe it had, ducted electric fans, and containing those fans meant they had to spin at a much higher speed in order to produce enough thrust.
Yeah.
But simultaneously, you were able to mask a whole bunch of the noise that came out because you could put all sorts of acoustic liners in the ducts.
Oh, that's
really
true. So it would be really loud, right? If you don't do
kind of whiny, right? Because it's a really high pitched scream from having such fast spinning blades.
Very interesting. Okay. Yeah. 36 of these blades all along the wing, and then these would turn so that you could do the vertical takeoff.
Exactly.
So you don't need a runway.
Yep, exactly.
And it's all electric. And I guess you kind of alluded to this, filling all these batteries in the cabin. Batteries are probably a really big problem for this, right? Because the energy density of batteries is not as good as liquid fuel.
Liquid fuels. Oh God, yeah. So it's an interesting one. So there's an energy density problem with well, first, the Phoenix was an unfortunately aptly named aircraft because it was only a few weeks, maybe a month after I started at the company, that the Phoenix caught fire.
Oh wow.
Yeah. In like battery fires are no joke, particularly when you have high performance cells. You can kind of pick two out of an energy density, a power density,
right,
and a stability.
They're going to be getting the most beta batteries basically because they need the highest energy density. It's like if anybody has the requirement for high power density, it's them.
Yep, exactly. And so high power density and high energy density as well, because you need to fly for as long as you possibly can. The range is super critical, of course. Yeah. And so you end up in this funny spot where like you've had to take this incredibly volatile thing, and I can't remember the final cause, but whatever happened, it was during maintenance. Something went wrong with maintenance that ended up shorting something and starting a fire. And I remember looking out of the office building. We were sitting in next to the sort of the big warehouse workshop. The plane was being worked in. People are just sprinting out the doors. The alarms are going off. And then all of a sudden there's this just enormous plume, huge plume of black smoke. Whoa. And then like licks of flames out the ceiling.
Oh man.
Incredible. And it was like, we're talking like whatever, an 8-12 meter tall building, something like that. So the fact that there are like a jet coming out the top of it was just insane, right?
Wow.
Yeah.
So this is like a whole plane catching on fire.
A whole plane. This is a whole basically flying battery catching on fire. And then obviously the carbon itself burns as well. The carbon fiber that the whole shell of the thing was created out of. So this is me just starting at Lilium. You know, really, this is like
this is like first week. You're like, huh.
So we're all going, oh shit. We've kind of run outside.
There's that expression, a dumpster fire. You know, you accidentally join a dumpster fire. But anyway, so you guys run outside.
Oh God, yeah. We run outside. We like get away from the building. We go to a muster point that's upwind of the thing. So it's going the other direction. We go, oh shit, that does not look good. And nor was it. You know, it was what a heck of an introduction to a company, and wild, and really, retrospectively, it's exciting, it's interesting. But God, at the time, you can imagine this is like the baby of so many people at that company. It was pretty bad.
Was this during onboarding? Like you're doing onboarding and getting your fire safety training, and
onboarding. They didn't. Surprisingly enough, so this is kind of the dichotomy I was explaining. They're a German aerospace company that's also trying to be a startup. There are 1,000 people at this point. They took 7 months or so to hire me, like the hiring process.
That's crazy.
Yeah, wild, right? Particularly coming over to the States, you're wondering what the hell is going on.
Yeah, it takes like maybe a month. That would be a long process.
That would be a long process. And if you're desperate for someone, you get them quick, right?
Yeah.
No. And it was months after accepting it that you even start. It's crazy. And then you get in, and the onboarding process is, here's something that needs designing. Go figure out how much copper you can pack into this motor. Go. And you're like, motor, copper, okay. What if we did this and that? Give me a presentation tomorrow. And you're like, okay. You got to try to figure it out. You know, it's kind of crazy. And so they're really... there was this insane dichotomy between the multiple personalities of this company. And it's almost a case study, I think, in how you can probably apply a lot of what you know about control systems to management. And you end up, if you end up with an unstable system, you can end up railing. Basically, you start with a small oscillation between like, we need to have processes and be an aerospace company, and we need to be a startup, and we need to be an aerospace company, and we need to be a startup, until you start railing at either end. And we are an aerospace company and we are a startup, and it jumps between the two in an insane way.
How did this manifest? Was it like executives saying things and changing their mind, or was it just like you have a deadline, but then you're like waiting on regulation for 2 months? Like
it's a bit of both, but I think ultimately it was factions within the company.
Oh, interesting.
They would never admit to it, of course. But my opinion is that it's factions within a company someone says that we need to be an aerospace company, and then they end up with the favor of an executive that has sufficient authority, or end up in favor in the public's or in the company's eyes, the employee's eyes. And so you start doing that thing, and then all of a sudden something happens, whether it manifests as an aircraft catching fire, and someone says, right, I told you we needed more processes, we're doing it now. And then you go, oh, okay, all right, we'll have some more processes. And now all of a sudden you're listening to that person, and And so there's almost this warring that manifests as these multiple personalities, but they're symbolized by these multiple people.
Yeah.
I think unless you're careful, you get it in any company, you know?
Oh, absolutely. Yeah, that's always going to happen. You're going to have, I mean, when we had outages at Seam, my last company, like then all of a sudden, all the things that were getting knocked off the backlog for like, you know, like, oh, we have like memory usage we don't understand or something like that. All of those get addressed the next couple weeks. Yeah. So it's a pretty normal ebb and flow, but in the context of this company, I mean, that is expensive, like time shifting directions.
Oh, incredibly expensive. And I think the other aspect to it that's hard is, like, neither side's wrong per se. You're right. You do need to get it certified. You do need to be an aerospace company. That is important. Simultaneously, if you're sufficiently overweight that you can't actually take off until you shed 10 kilos, well, you're going to have to figure that out.
Right.
Particularly for the Phoenix side of things, which is an unmanned prototype. It's not like, oh, we'll take out a seat. There's no seats in the first place. Like, what are you planning on doing?
Taking everything out.
Taking everything out. So, I don't know. There's definitely some lessons in how to stick on focus and figure out like the biggest material problem in front of yourself until you get it done.
Yeah. So so that's a pretty good story. An onboarding story. What else happened there? Like, were there any really big highs? What were you doing at Lilium?
Well, I was actually working as a mechanical engineer.
Oh, really?
Yeah. I was working as a mechie.
That's why you know so much about the mechanical stuff.
Yeah. First, I started out in propulsion quite briefly. That's when this sort of fire happened. And then...
You're a rocket engineer?
Propulsion, not rockets. So it's just the electric fans.
Those are the same to me. Those are different, propulsion and rockets. Yeah. Rockets have an explosive thing. Propulsion is just the force, I guess? What's a...
Well, the propulsion in this case is a ducted fan. It's
just a fan, there's no rockets. There's no fuel. Okay.
So the team owned everything from basically the joint to connect to the wing, the actuator that sort of rotates it to point up or down, both for control and vertical takeoff and landing, the mechanisms to sort of open up and close the duct that changed the expansion ratio at various sections of the flight profile, and then all the way through to the electric motor that actually spun the thing and all that type of stuff. And with I think most aircraft projects, the nemesis is weight. Like, how do you get weight out of something?
Yeah.
Actually, a lot of projects for mechanical engineers at the end of the day are how do you strip weight, because weight is, for anything that moves at least, is just like the absolute enemy. It's an EV for range, and that includes VTOL for your device in your pocket. It's something you have to carry around. It's extra, and is often traded off against battery. So it even like disproportionately affects range because you have to delete some batteries to keep the same total mass of the thing.
Right.
Which is kind of crazy. But you asked, one of my proudest things here. It was pretty fun. I think that when you do end up in those situations where you say, okay, guys, I remember there's one conversation and maths I ran with a friend. They said, okay, for the first prototype run, we're going to just machine all of the bladed discs out of solid titanium because that's what we've designed them for, and we know that they can survive bird impact. You basically have to be able to chew through a 200-gram bird like a sparrow or something like that and just eject it out the back.
Well, and you must have run so many tests.
Yeah, a lot of simulation in those days. This is a long time ago, before most of the major.
I'm just imagining you very like complex mechanical CAD software, and then you press a button and a bird
and a chicken.
You must have had to model that though. You must have had like an object, right? I mean, is that?
Yeah, there's sort of a semi-split simulation team that handled all that, but you get the results back, and it's just this sort of like the model is just a big slug, and it's sort of, you see all the blades bend around and whip and all sorts of stuff.
Modeled as a slug.
Modeled as a slug, not a literal slug, a cylinder.
Gotcha.
And so anyway, there's all sorts of stuff around there, but I remember having one conversation that was like, well, okay, if we go ahead with this plan to actually machine all of the fans out of billet titanium, not only would we need to buy the world's supply of this grade of titanium for the next 2 years or so. It was years of it. Oh, wow. It was insane. It was some huge portion. But we would also need to buy every machining center from which company was it? I couldn't remember. Whichever company that decided they needed the machines of, we're going to need to buy every single one of the machines that company produces for the next 2 years as well.
Wow.
And then spend a couple of years doing nothing but, it takes 24 hours to machine one of these blisks. Machining.
This would be
constantly.
to go to a production run. You could have used it for prototypes, but
Yeah.
in production it wouldn't have worked.
Very, very low volume. I mean, you're talking about literally a day of machine time to huck out.
Wow.
Yep. So long.
And it's just because the titanium is so tough, or what?
Well, yeah, titanium's hard to machine, but also there's you have to use quite small tools to be able to reach inside between the blades and things like that.
Okay.
And so you end up at the end of the job, you have to end up going really slowly with it, really long and therefore not super stiff tools.
Probably on some like crazy 6-axis mill or whatever.
Exactly.
Okay,
Yeah.
fair enough.
Beautiful machines. But when you look at that problem, you sit back and you go, yeah, okay, we probably can't buy all those things. We can't get those resources. It lends you an opportunity to do a bit of like sit back and think from fundamentals on like how you can come up with something really cool. And the one that I actually end up with a patent on is a novel hinge.
Really?
Yeah.
A hinge.
A hinge.
Can I pull up this patent?
But yeah, if you jump into one of these images,
Yeah. Okay, this is it.
if you go down to the bottom, so this is one of the flaps, which is a big carbon structure. And then, if we look at this, what I worked out is that it's really like it's a fun, almost like logic level problem of if you can constrain these bodies in only, you want to constrain it in only the right orientations and leave it completely flexible in the others. Because if you over constrain a system, if something stretches on one side, it'll force a stretch on the other and you end up straining your joints way too much. So what I worked out with this bearing arrangement is that if you had a couple of spherical bearings and a crossed roller bearing, which is just, you can imagine them as like a crossed roller will only allow it to rotate in the one axis, and a spherical will allow it to rotate in any axis but not translate.
A cross roller, I don't know where you would see these, but it has like a V indent. Is that right?
Almost, yeah. It actually has two V indents and the rollers kind of cross over one another.
Interesting. Okay.
Yeah. They're really cool bearings, like annoying and expensive and precision, all that stuff. But when you're trying to like really squeeze out the last of the space in these systems, you get there. And so anyway, this pattern it's a fundamentally the simplest possible bearing you could have in this situation when you want to constrain things in this way. And I remember walking into a meeting and someone I saw as a bit of a mentor figure, Tim, I didn't work with him directly, but I saw him occasionally. He was working in an adjacent team, a bit older and a great bloke. He looked at the design and went, "Huh, that's ingenious." And I was so proud of that.
That's all it takes.
That's all it takes.
That's all it takes.
Any young engineer, you tell them that, and you're like, "Damn, okay, we nailed it."
Yeah.
And that's why it's a patent there. But unfortunately, with the insolvency, of course, it's extremely unlikely to end up in use anywhere.
Yeah.
And who knows, maybe the patent will be sold off to someone, but it's one of those fun things.
Right. I guess everything will get sold off. I don't know what happens in bankruptcy, but I imagine that's what happens.
Yeah, I imagine things will be sold off.
Wow, super cool. It is very hard for me to parse this diagram, but I won't. I won't belabor it too long because we're an audio medium, but it looks really cool for listeners at home.
Yeah.
That is pretty cool. Okay, so that's a big high, and then I don't know. Is there any juicy drama or something like that? Like, what do you think they did wrong? This company, Lilium, Lilium, excuse me. They had VTOL prototypes. They had billions / $billion of funding, and it all fell apart. What happened?
I think it was a genuinely hard problem, and I think that like sometimes you just fail, or in fact most of the time as a startup you fail. So like I don't think there's any single cause. I think that success is the hard thing that you should be looking at how they succeed. But with that in mind, what do I think the single biggest strain is on the on the company was as I was describing before, as you jump between these things, you actually end up moving nowhere. You don't get part of the way on each. You end up doing basically nothing, or very, very little. Yeah. And I think one of the most potent tools to solve that situation is to be able to iterate and cycle way faster. Now, on one side, the aerospace folks have to admit that there's a performance and a technical and a research problem necessary to cycle. So you say, okay, you guys, we're going to get out of your way and you go do your R&D. And like, that's fine. We'll work it out. And then when the R&D is done, then okay, you stop doing R&D, or you stop doing R&D on those things, and you actually go work out how to certify those, and you sort of pass it over. But with R&D, the thing that you need, and any company that needs this, they need fast iteration. You need to be able to try things, and it needs to be beyond acceptable. It needs to be encouraged, and it needs to be on ideally an hour scale.
Yeah.
It's kind of like it actually comes down to a human psychological thing. It's like if you're engaged and interested the whole time, you're doing your best work, you're going to kill it. And if you are working on a week scale and you're like, oh, we'll release this thing in 6 months, and actually I'm just writing requirements for a supplier, like, you're going to go nowhere.
Yeah.
It's a fly or sink kind of moment. And so one of the other things that I did at Lilium, and I had to petition all the way up to, at the time, the CEO, Daniel Viercard. I just kept sending an email until higher, until I called him. Yeah. I sent him an email, and then we had a Zoom call for 15, 20 minutes and said, I need a workshop. Just a simple one. I've got currently nowhere I can go and 3D print something simple, slap it together, drill some holes, whatever's necessary to just try something out and see how it's going to work.
Yeah.
And so you can like model those things in CAD software, but it's obviously not the same thing. So we ended up with a workshop and a slightly more fun and larger scale. I remember one time with the Phoenix redesign crew that I got put on after the fire to make sure that didn't happen again was basically the objective.
Oh, no way. So you got put on.
Yeah. Yeah.
So they were like, new guy, that's your problem.
Yeah.
Wow.
Well, the thing is, it was like this can't happen again, and we need to invest a lot of effort in basically the battery system and power distribution to make sure of that.
I see. So a lot of resources were moved towards that. It almost feels like the murderer couldn't have been in the building situation.
Okay.
Where they're like, oh, here's a new person. They couldn't, be biased in the investigation or something.
Maybe optimistically, I think honestly a big part of it as well is as the new person, they're like, okay, you haven't got what we see as a critical role at the moment. Like you can go do this other thing because you haven't really fully engaged in something that was.
It's like how I onboard people.
Yeah.
I'm always like, you got to find something important. I don't know what it is, but I'll keep throwing you around until it sticks.
Yeah. So one night, because this was all mid-COVID as well. This was to date it was all 2020. Yeah. I remember it was summer of 2020, things were opening up just a little bit, and I was with the crew that was doing the sort of redesign, the rebuild on this, including one of the co-founders of the company. We're out in a German beer garden. You can imagine we're in a park. It's beautiful.
A German beer garden, if I understand properly, is like a bar, but you can play games.
Well, it's outside.
It's outside?
Yes.
Okay.
Yeah, it's lovely.
It's like an outdoor garden, all right.
Yeah. We were sitting around, and the iteration cycle thing was just killing me. It was so clear that the company was just deathly, in a sense, focused on making sure that absolutely nothing bad happened to their second prototype. Not because they couldn't afford to rebuild a third or a fourth or a fifth, particularly if you decrease the cost of those individual prototypes and you just start cranking on them, right? Yeah. You can make more of them, no worries. But they were just terrified that it would spook investors, it would be terrible for morale or whatever. I think the lesson there is that you can eat it. If you say, yeah, we're going to crash 2 more, who cares? Let's move on. Everyone's going to go with you.
But it wasn't obvious at the time. It was before that SpaceX narrative had come out. Because I think that changed that. Maybe it was.
Maybe. Well, this is the problem. At the time, I think you had half of the people from Airbus saying oh, no, we can never have a test aircraft, even an RC one, crash. That would be horrifying.
Right.
It would never get certified if we did that.
Yeah.
Which I can't speak to the authenticity of that. Maybe it's true. Maybe the EASA and FAA do look horrifyingly upon that. But the prototyping half of us were to hell with that. Let's go. We got to make the damn thing fly again.
Yeah.
And so I came up with a half-brain pitch, a bird-brain pitch.
No, that's right.
Over a few beers with the guys, and we had a quick look, and you can actually buy an old Russian transport plane similar to a C-130 cargo plane with a drop tail and all, can land on unprepared surfaces for only 400,000 euros at the time, right? In Poland, certified, we've got pilots on staff. Why don't we just kick the prototype into the back of the plane here? So instead of flying around this nice little German town that obviously we can't crash in, we just fly the whole jet off to I don't know, Northern Africa, for argument's sake, somewhere with a big desert. You just got to pick somewhere with a big desert, right?
Sure.
And kick the thing out, fly around. If it crashes, okay, so what? You put the thing, if it doesn't, crash back in the back of the plane. You fly.
Is it really
Germany.
Northern Africa? Like that would be the next place that would be not anal about this kind of stuff?
Yeah. Well, you want somewhere. See, this is the thing about fast cycles. You want completely unanal. You want basically you want a standing agreement that you turn up when you like and you fly the damn thing, right?
Fair enough.
You don't want to have to deal with paperwork on a flight by flight basis because it's going to kill you. You need the mentality of we can try things.
Absolutely. Yeah.
And so, anyway, unfortunately, that idea was nixed, but only for a few $100,000, you can get yourself a cargo plane and fly stuff to wherever you need.
You know what this reminds me of, though? Is it Boca Chica? Is that right? Yeah. Like Elon wanted to move all his rockets out to the middle of the ocean, essentially. And they were like, freedom, yeah, easy. We're going to build a launch base here. But then, like, corrosion. I guess this is a different situation, but corrosion really messed that situation up.
Corrosion's really eating into things for them.
Yeah, you guys wouldn't have that issue. That's so interesting. So you were petitioning for this. I guess you really were the advocate for the prototypers. You got the workshop. You didn't get...
We did get the workshop, yeah.
You didn't get the small kind of, I don't know what you would call it, like the Area 51 of testing.
Yeah, I was pitching it as a bit of a skunk works where we wouldn't invite the old aerospace folks because we didn't want to talk to them at that time. You know, there's a time and a place and it wasn't there.
There was truly a cultural divide.
Oh, yeah. And this is an inordinate riv. And I mean, this is now 4-ish years ago, right?
Yeah.
So no need to say what happened since. I've got no idea.
The problem with prototypers, though, is they get upset more quickly. Like if they're not doing anything for a year, they're like, I'm out of here. Yeah. So I bet the people who stick around were maybe more conservative, if I had to guess. Yeah, and that's ultimately, I think, what is going to kill any company that needs to do genuine R&D. Yeah. So lessons for the wise. Wow, that is a great set of stories to sort of wrap up Lilium, unless somebody saves them again, in which case, in which case I'll have to re-listen to this, make sure I didn't leak it. We'll have to take it off, yeah. Seve, fantastic. Matt, mate. I'll speak to you soon. Talk soon.